So for today's experiment, I am comparing forest and field soils. And this experiment will go over the aggregation and aggregates in the soil itself. So I am to put 15 grams or just over a tablespoon of the soil into the strainer. And then I am to dunk it, make it moist, and then to kind of dunk it for about 20 times at 2 seconds per time. So here we go. And then I'm to carefully dump it out onto a paper towel. And then I will let that and that sit for about 10 to 15 minutes. And then I will do the field soil. And then we will observe the aggregates of both. So here we have my just over 15 grams or just over a teaspoon of my field soil. As you can see, the forest soil, and you can kind of see how cloudy the water is right there. I'm gonna go ahead and replicate the field soil as well, and then we will compare the results. There we go. I'll go ahead and dump this one out as well carefully. And then we will compare the aggregates here in just a second. So while we're waiting for both of these samples to settle for the 10 to 15 minutes that we are advised to, we're going to observe the quantity and shape of the wet soil mass with the presence of soil aggregates. And the soil mass should be greater with less slumping and with more visible aggregates with greater aggregate stability. So let's go ahead and dive into this. So I'm doing the forest soil first. And one thing I can definitely notice is it's extremely gritty. Extremely gritty in here. It does seem the aggregates are a lot more visible. You can see a couple of them right in there. A little bit more rocky than what I expected it to be. And it does tend to hold its shape a lot better. And it does have a greater soil mass with less slumping. It's easier to stick together and able to hold its form a lot better than it was originally before it was wet. And now we're going to move over here to the field soil and compare the same things. Get my hand a little cleaned off, flick it off. And here we go with this one. I will say with the field soil, it feels a lot more clay-like. The forest feels, it does have, I believe it does have some clay in it, but it feels a lot siltier. And here we have some pretty big aggregates, like right there. I can't break that up at all. I mean, I'm putting pressure to it and it won't break up. That's a little rock right there. Definitely more visible. Definitely is able to hold its shape a lot better and is more stable than it is when it was dry before we put it wet. And there's definitely a lot less slumping going on in both of these samples. And just being able to feel it and kind of try to do a little bit of ribboning with it. So the soil mass definitely is greater with less slumping, and the aggregates are a lot bigger, a lot more visible, and the stability is a lot greater on both of them as well. From this sample right here, where I'm putting a lot of pressure right there and I can't even break it. And then over here, you can see definitely a lot more of the aggregates through it. And it feels a lot more silty, a lot more gritty, if you can hear that at all. So as the instruction had said, allow the settlement to settle in the transparent cups for 10 to 15 minutes. I allowed it for 14 minutes, and it's still settling as of right now. You can still tell the water's extremely murky on both of them. And right here on the field soil, you can see some of the other stuff floating on the top right there. But right about, I'm going to use my knife blade to pinpoint it because my fingers are fat. You can tell right about there. Right about that little white line that's on the bowl itself, you can see where a lot of the soil is settling that came out into the water. And then onto the fields, onto the forest soil, it's pretty dark, kind of like a milk chocolatey. I definitely wouldn't drink it. You can tell it right about here. And my lighting's not the best, and neither is the camera. But right about in that area is where a lot of it settled to, which it settled down significantly because it was a lot murkier on both of them. And next I'm going to let out some of the water and compare the samples again. So as you can now tell, there's a difference. I've went in and done an extra step or two, where after the sediment had settled in the bigger cups, which are now down there, I had proceeded to, like it said, decant most of the water out of each cup and transfer the sediment into 50 milliliter graduated cylinders. Now, unfortunately, I do not have those here with me, so I had to improvise and use something different. And you can see right here is still the forest, right here is still the field. You can definitely tell because of the different colors of the water and and you can definitely tell right there the sediment in the bottom. And if I lift it up slowly, you can definitely tell from the bottom. You can tell right there how much sediment's in there, and you can definitely tell from that angle too. And I'll be providing measurements in the paper I have to go along with this. And here is the forest. Still some stuff on the top, but I've drained about all the water I can without losing some of the sediment. You can definitely tell right there. I don't know if it'll focus, but you can, yeah, right there. You can tell the difference in the layers. And you can see how much sediment's really at the bottom of there. So I can conclude that from the 15 gram samples of the soil of each from the field and the forest, that in the case of where I took my samples, the forest does have a lot more sediment in it. It's very evident. And I'll be concluding my other findings in the paper being published with, in the document being published with this that's being submitted. For this next video, the next experiment, I was to take 3 surface soil and 3 subsoil samples from each site. And this is what I'm using from the field and the forest, as you can tell. And so that totals 3 and I choose 3 aggregates per sample. So that's 9 aggregates per tub I'm using over here. And I was told to place it in shallow water. And I am to watch them closely and just note if they float or sink on the surface and how they break up or slacking. And then in the next 2 hours, I will record whether it was complete or not, partial or absent. So to show you right now, here's my surface and here's my subsoil. There is the field, and there's the forest. I have them barely submerged. For the surface and for the subsoil, there's the field, and there's the forest. All of the aggregates sank. There's some little particles off of them that are kind of floating, but you can kind of tell where part of the soil and other stuff is kind of breaking off of it fairly easy. and then I'll be back in 2 hours to tell whether the slaking was done or not. So here is us at the 2 hour mark with the slacking and the aggregates in the bowls themselves. You can kind of tell there is slacking going on. It's a little harder to see in the forest soil just because the water is so much murkier, but I'll be able to drain it and be able to tell a little better. But you can definitely tell in the field soil from the subsoil to the surface, there is a good bit of slaking going on. I don't know if it'll be total dispersion, but it'll definitely be partial. Here we are again. It's been 20 hours since these samples were put into the water. I checked them at 2 hours and did see that there was some partial slaking going on. There's your subsoil, there's the surface soil, and you still got your lighter is the field, your darker is the forest on both of them. And it's pretty well. There is slaking going on and dispersion, but it's only partial. There's a lot of big clumps still in there. On the forest side of it, there was a lot more of the dispersion going on. So as much as to where I would call this a type 2, I'd call that a type 3. Just because there's still some aggregate left, but it's pretty well almost all of it's pretty well on the bottom of the container. Same deal here as in the surface sample is what I'm seeing. I mean, after you kind of work it a little bit and kind of move it around, and it disperses a little more, but it doesn't really do too much on its own. And while here, if I can get the light to hit that right, you can see how much is actually on the bottom laying now. And there's just virtually very little still in the middle, but that's why I'll say